Hello, good morning. I'm Kenny Grip. I'm one of the product managers, MySQL product managers at Oracle. This session is about MySQL high availability and disaster recovery solution. We've got about 25 minutes, and let's see. So first of all, IT disasters, and it was brought up at a previous session by the Booking.com people that disasters happen, and here's an example of a survey done by the Uptime Institute showing the kinds of causes of IT disasters. Is it like power, fire, cooling issues, network issues? So there's all kinds of issues, power being the biggest issue, biggest cause of problems with failing data centers. There's also the increasing price of disasters, where in 2019 versus 2020, you can see that the cost of a disaster has increased quite a lot, with more customers or more users reporting that over 1 million costs when there's any disaster happening. There's also some examples of, for example, OVH had a downtime, a fire in a data center, and that costs a lot of, so OVH is a kind of European kind of cloud provider, and they had a fire, and it caused a lot of downtime, and it caused a lot of issues for their clients, and did cost a lot of money, more than 100 million euros. Same with Delta, British Airways, HSBC. So a lot of examples where disasters are causing a lot of downtime. And this is what I'm going to show, a couple of things that helps to kind of address the MySQL part, where the database side of things, how can we reduce this cost? How can we make things better for the database and easier for you to use? So first, kind of a little bit of a history. MySQL has been around for, 20-something years, and MySQL replication has been there for 20 years, about 20 years if I'm not mistaken. And what MySQL, I think is really being used a lot with replication architectures to provide high availability, scale out, read scale out, all kinds of things. Because it's so flexible, you can do whatever you want in terms of, like, you can do multi-primary replication, asynchronous, even though I wouldn't recommend that. There are a lot of issues with it, but a lot of users come up with kind of all their architectures that they do, and to achieve kind of the needs that users want. And in the past, we've provided these kind of technical pieces for you to set up your own environment, and that included a lot of automation needed by DBAs, system engineers, to get this environment up and running. Whereas sometimes it's a full-time job for a whole team of engineers on automating and maintaining the database architecture. So back in 2016, we have introduced MySQL InnoDB cluster, which is changing that. We still have those technical pieces, but we take the technical pieces that we have, and we introduced a new thing called MySQL group replication, which provides a kind of cluster. So MySQL group replication is basically built on MySQL asynchronous replication, but it's adding, making sure that there's no data loss, there's quorum. When a transaction is committed, it needs to be acknowledged by the majority of them. It provides automatically memberships, so when a node joins, it gets provisioned automatically, so no need to set up users, provision the data, everything is built in and done automatically. It handles network partitions, no split brain. We guarantee consistency as well. You can do multi-primary, write to all nodes at the same time. So that is, all of that is possible. So that's group replication. So that's the thing we introduced in 2016. But then on top of that, we added MySQL InnoDB cluster, which is basically combining a set of products that we have and making it one big solution that is very easy to use. So in this case, MySQL Shell is kind of the main client where you configure your cluster. And I have some examples later on, but basically you use Shell to connect to the database and configure this cluster. And in a few commands, you can create a cluster with 3 nodes or more, and you can have the nodes automatically being provisioned. You can configure your router bootstraps automatically. So basically, you say MySQL router bootstrap, and it configures itself, and it learns about all the changes. So very easy to add and remove nodes, to configure and set up this environment. This can be done in a few minutes with a small data set, so that's no problem at all. So Shell provides this interface. It takes all these technologies, makes one kind of solution out of it. And another interesting part that we have is InnoDB Clone, which was introduced, I think, 2019, where we can now take a physical snapshot of a running server. So if the secondary wants to join, there is no data. It can basically say, give me a snapshot. And over in MySQL connections, it will provision, basically copy a physical snapshot, provision the node, and configure replication, all in kind of one command. And each of these pieces can be used separately if you want a custom architecture. But what we focus on is providing the kind of an environment that most people or most businesses need. And in this case, this MySQL InnoDB cluster, we provide no data loss, so recovery point objective 0, and RTO of seconds. So the failover happens within like a minimum of 5 seconds, but usually it takes like 5 to 10 seconds. Depending on the workload, it can take a little bit longer. So automatic failover, no data loss. And this is what is most used for high availability. So when a failure happens, a single server fails within a data center. So group replication is basically an implementation of replicated database state machine. It's all writes in the cluster are ordered. And very important to note that this is a way of replicating data. It's not a way to kind of shard or scale data. It is every database has the full data set. It's a way to achieve read scale out and high availability. So you can configure the consistency you want. You can write on a primary and read from secondaries at the same time. By default, you'll get eventual consistency, meaning that you can read data that is not the latest on the primary, but you can also enable full consistency and say, I want to read the absolute latest data. So you can enable that per session, global, however you want it. All of this is using the MySQL replication framework. It's built by the same engineering team that builds the MySQL server and MySQL replication. It's using binary logs, relay logs, global transaction IDs, everything that you know if you use MySQL replication, which almost everybody does. It's the same with MySQL group application and InnoDB cluster. So this has been GA since MySQL 5.7, and we support it on all our platforms that we support. In 2020, we introduced MySQL InnoDB replica set, which is kind of the same ease of use with MySQL shell and how to deploy an architecture, because that is what the feedback that we saw is that, okay, InnoDB cluster is so easy to set up, and it provides all these guarantees, but what users were asking too is like, I don't have the most stable network, or I'm okay with some data loss, and I have better write throughput because asynchronous replication is, of course, going to be faster. Transactions can commit locally. They don't need to be acknowledged by other members. So you have a better write throughput. You have a bit less guarantees. So the amount of data that you can lose is going to be like seconds, for example. And the time to failover, it's manual failover. And the reason why it's manual is that we don't have any monitoring node making any decisions that may or most of the time makes the wrong decision as well. So this is manual failover. Use this when you're okay with some data loss and some time to fail over. So most users will choose MySQL InnoDB cluster, of course, automatic failover, no data loss. It seems to be most common. Now in 2022, last year, we've introduced MySQL InnoDB cluster set. So this is an addition on top of MySQL InnoDB cluster where we allow, or we add the features to MySQL shell to configure a cluster and then add a secondary or multiple secondary clusters. And what we do here is we have disaster recovery. We configure asynchronous replication between two or more regions. There is no limit on how many regions you add. by this, we have, using MySQL shell, an easy way to say, okay, I want to switch to have the replica cluster in Brussels to become the primary cluster. It's one command, and it reconfigures everything for you. And all of this is kind of that one command. We also achieve no impact on write performance. So high availability, no data loss within a region, so with InnoDB cluster. There is some data loss possible between regions, of course, and that is, for most companies, for majority of the companies, we've seen that this is generally acceptable. If you do not want any data loss between regions when a region fails, then you need to deploy a single MySQL InnoDB cluster across 3 data centers. That's the only way to have no data loss at all and automatic failover. Is to use 3 regions and split the members in InnoDB cluster across regions. So it's very easy to use. Again, it uses MySQL shell, clone. Everything is just one command to add and remove nodes, add clusters, and so on. What we also have is MySQL router. It's fully aware of the entire architecture. So you can control or configure where router needs to go. So writes will only happen on the primary cluster. So your router can be used, or by default, will connect to the primary cluster for its reads and writes. But you can change it and say, reads need to go, stay local. Maybe you have some reporting that you need to do, and you don't want to go over the network, so you can kind of send it to the replica cluster. So that all works very easily, and you all do this within MySQL shell. You don't have to change MySQL router. You just change some metadata in the cluster, and then the router will automatically learn within seconds the change of its configuration. So you can do 3 regions. So here we added Lisbon to it. Not every region needs to be 3 nodes as well. So you can have Rome primary cluster. We have high availability. In Brussels, we have 3 nodes, so we have high availability within Brussels. But you can say, let's add Lisbon. It is a single node. That is OK too. But you will not have high availability within Lisbon. So you can kind of add kind of some like read replicas that you want to have. You can also make it the primary cluster. But yeah, you give up the kind of the automatic failover here. So there's a lot to cover. So I have some examples. I'm not going to do a full demo because we only kind of have like 25 minutes. So here's an example on how to set up a cluster. So you would first connect, laser doesn't really show, but first a line is that you connect to the database, to a database with MySQL shell. You can create a schema, you do whatever you want. But what we want to do is first create a cluster. And by default, we are in JavaScript mode. So there's JavaScript, Python, and SQL mode. So here's JavaScript, where we say DBA create cluster. We call it Brussels, and we name the object Bra. So we can add instance and add a secondary, then a third one as well. So this is the only commands that you really have to run to provision a 3-node cluster. So with these few commands, there is some extra to configure MySQL. So we've added a lot of features to MySQL 8 where you can change the configuration through MySQL. You can restart the database to do certain operations all over a MySQL connection. So no SSH access needed. This is all going over MySQL connections. And just with these few commands, you have kind of a cluster like this up and running. So very, very easy to set up. So we can look at the status if we want. With status, we have various extended status describing data. Like there's a lot of things you can do there. You can change the primary. You can control some parameters all from within the shell. And shell takes care of deploying this across all the members. Now, if you want to create a cluster set, so have this disaster recovery, we have this Brussels object. And we want to create a cluster set out of this. So the only thing we need to do is say, OK, we create a cluster set object, and say we want to change this to a cluster set named cluster set. Here's what you get. And you get an object back, so the cluster set object, which shows that it became a cluster set. You can then look at the status, and you can see that we have only one cluster in it now, so which is the primary. And then which is the primary instance within that cluster, what the status is, and so on. And now what we want to do is we want to add a replica cluster. In the example, Lisbon. So we add Liz and say we create a replica cluster out of our cluster set. And this is the host that we want to use as the first member in that cluster. And we add 2 instances. So again, a couple of commands, and we have basically a 6-node cluster up and running. And we have everything configured, the asynchronous replication, the group replication, automatic failover, everything is provided. So we can then look at the status of the cluster set, the status of the individual clusters individually, or you can use extended output. There's all kinds of options that you can look. So you can do \?, and write the command, and it will show you the full manual on all the options that you have available. We can change the primary instance within a cluster. So we can say set primary instance and say I want node 2 to be the primary instance. So you just run it and it will do everything for you, reconfigure, make it the primary. Router will learn about these changes automatically and send the workload there. This is an example of what goes on. So we have routers connecting to the primary, and then we have routers that are connected locally depending on their target configuration. So we have target Brussels, target primary. And if we want to say we want to change the primary cluster, and we want to say Brussels needs to be the primary cluster, you send one command, set primary cluster. And what happens is everything gets reconfigured, the replication gets changed. This Rome is now a replica cluster. Brussels is the primary cluster. So very easy, just one command, and all the rest happens for you. We can guarantee that during this process that there's no split brain situations or whatnot. What we do is we basically make sure that the replica is caught up. We stop everything here. Then we promote the replica cluster to become the primary. So all one step, one command. Routers will automatically adapt based on that. So here's an example output. Again, I mean, we're not going to go into much detail due to the amount of time, but set primary cluster, it shows you all the steps that it's taking to perform this action. Now let's say a primary crashes. A primary member in the primary cluster crashes. So automatically what we've done, we've added functionality in replication where the replica cluster has an asynchronous replication running, but only one. And if the primary changes, we don't have to reconfigure its replication configuration. It will learn about the group membership and it will automatically reconnect to the new primary that it has. So this is kind of fully automatic. You don't have to do anything when a primary crashes in a primary cluster. And the same when the primary and the replica cluster crashes or goes away, network partitioned, then automatically replication will be reconfigured on the new primary as well. So all of this, no interaction needed by any monitoring node. Shell doesn't do anything. The only thing Shell does is configure everything and say this is what it needs to look at, and it does manual operations. So the automatic operations are performed by the nodes themselves. Let's say there's a whole data center that crashes. Maybe there's a fire in the example of OVH. When that happens, we can fail over. So you have switchover. We set the primary cluster. This is a clean planned thing where we can guarantee that there's no data loss. Well, here we need to force it. We need to force Brussels to be the primary cluster. There's a couple of things that you can do first. We've added features such as fencing to it, where you can say, okay, it's not a fire, it's a network issue, and these databases are still running. What you can do is you can fence them first and say, stop everything here before taking an action, or you can make this the primary first and then fence this. It's just to avoid this split brain, because it's asynchronous replication between them, and you're forcing something. You have to make sure that you're not creating two clusters suddenly that behave next to each other, because there's this kind of network partition. So we have the fencing features. It's just one command again, fence writes or fence reads and writes. So it's a choice on what you prefer, and it does different options. It does different kind of settings, changes different modes in the cluster for that. So yeah, we run force primary cluster, and then it reconfigures it, and that becomes an invalidated cluster. Let's say the network comes back. Those routers will automatically learn that this is now the newer primary cluster, and they will automatically reconnect traffic. So you don't have to do anything to get everything back up and running. That cluster is still invalidated, and you can bring it back if there's no split brain. So you can bring it back just by rejoin cluster. It's just one command. I think this is where group replication, or there's a network issue or something going on, but the routers are still intact. Traffic automatically is adapted or changed in the kind of, all the routers everywhere in any region are automatically changed as well, as long as they can access that new primary cluster, of course. So yeah, how do we do this? Basically, cluster set dot force primary cluster, and we say which one needs to be the primary. So this is the only thing you need to do. So the failover is manual, because we cannot decide when it's good to failover. We don't know what's going on because of the asynchronous replication between it. It's something that you have to do manually or automate. So you can automate these shell commands if you want. But yeah, one command, and it does all the steps for you. So it removes a lot of the stress when there's a disaster, where you just need to run one command, or with the fencing of a couple of commands. So there's not this long process, 10 pages on all the steps you need to do to reconfigure replication, reconfigure the application. All of that is not necessary. So all of this is done within InnoDB cluster set itself. So just to finish, a little bit of an overview on like what different solutions there are for the different types of needs that your business might need. So we have recovery point objective and recovery time objective. So when there's a failure, recovery point objective is how much data did we lose since that failure. So RPO 0 means no data loss. If it's RPO with cluster set, for example, it's asynchronous. So RPO is going to be a couple of seconds. Could also be more, depending on kind of the network bandwidth and whatnot. And RTO is how fast can we recover? How much downtime would we have when this failure happens? There's different aspects that we need to take into account. We can't say RPO 0 everywhere, RTO should be seconds. I mean, it can be, that could be a requirement, but often we need to look at it from a high availability standpoint. So a single server failing within a region. And then we have disaster recovery, where a full region fails. So you might have different requirements for high availability than for disaster recovery. Then there's also, of course, the human error, where somebody does drop database, or a bug in the application deletes more data than necessary. So we call that little Bobby tables for the XKCD kind of thing that has been around for a while. Where an SQL injection could remove data, for example. So what you need to do with a human error, you need to recover from backup. Or there's an option to do delayed replicas. There's kind of all kinds of features. Now what we cover here is HA and disaster recovery only, not human error. We don't have anything for that at this moment. So if we think about high availability, so we're talking about a single region setup. If you want no data loss, and you want automatic failover, or you want automatic failover, you have to use MySQL InnoDB cluster. If you're okay with some data loss and have manual failover, or you automate that process yourself, you can use InnoDB replica set. It brings you the best write performance, of course, so that's the benefit. Now, we do a lot of optimizations and group application to make it fast, but every transaction that is committed has to be acknowledged by the majority of the members. So there's this single round trip to the other members, and that adds latency to the commit phase of the transaction. Here we don't have that, so you will have a better write performance. In a local network, we're talking about 0.1 millisecond that would be added in general to a transaction. But that could add up a lot, depending on your workload. If you have multi-region and you have the same requirements, no data loss, and I want automatic failover, then you have to use 3 data centers in our solution here. You have 3 total, and you put an equal amount of members in each InnoDB cluster members in each region. So we have 1 in each region here. You can also add 2 in each region, which is fine. And what will happen is that if one region fails, then the other region will have a majority, it will have quorum, and it will promote another one to be kind of the new primary cluster, fully automatic. It also needs majority when you commit a transaction. So when I commit a transaction on the primary, it needs to have an acknowledgement from at least one of the others before it will continue. Now, if you have 10 milliseconds delay in between, you're going to have 10 milliseconds added at every commit. So that's to be expected. Of course, if you really have these requirements, often you might have a couple of milliseconds extra if you have kind of closer data centers that are in the same city or something like that, and you have a dedicated line. So that's more doable. The impact will be less. Now, you need a very stable connection between them, of course, because there's constantly messages being sent. Any network issues, packet loss will impact the performance of the system, of course. So there's a risk to it. You can't have this and have an unstable network or do it over the internet. That will not work. So you have to be aware of that. So it is a solution to some of our customers, but I would say that a majority of our customers are okay with some data loss when the issue happens. Data can still be recovered unless it's burnt down, of course, right? So data is still recoverable up to some extent in most situations. So here we provide high availability, fully automatic, but some data loss with a manual failover between regions. And that's it. That's my presentation. So that's it. Thank you.